All right, now we're going to talk about ArcPy and ArcGIS geoprocessing. Don't be concerned because this is something that you are already a pro at. It's just that ArcPy is how we're going to gain access to our geoprocessing tools, also called GP tools, when we are scripting our geoprocessing tasks in just a Python window. So how do we know how to do this and what we need for each of our individual tools? Well, the key here is the help documentation. So the ArcGIS Pro help documentation will be required for you to gain access to for nearly every script you write that involves a GIS tool. You will need to become adept at querying for the ArcGIS Pro documentation, the most current version associated with your tool. So I've given you an example here of the URL that takes you to the latest version of Pro for the help documentation. You'll notice that it doesn't list the actual version for Pro, it just lists latest. So for whatever's the latest version, that will be the URL. You can always Google ArcGIS Pro clip and you can put in the version of Pro that you have as well. But that's what you're going to do in order to gain access to the help documentation to help you understand what it is that you need to put in for all of the tool parameters. So let's talk about our geoprocessing tool names. All of our tools are going to have a name that is something you already recognize. So it's the name of the tool. But notice that there's also another part of that name. So in this example here, we have buffer_analysis. So it's not just the tool name. When we're scripting with Python, we also need to know the toolbox that the tool lives in. So here we know that by looking at this, we want the buffer tool, and with _analysis, we know that it lives in the analysis toolbox. Now, how do you know that? Well, you can either open up ArcPro and search for the tool and figure out what toolbox it lives in, or you can always go to a web browser and query for ArcPro buffer and then get to the help documentation for the tool, and it will tell you the name of the tool within ArcPy. So every toolbox within your ArcPro installation, within your ArcGIS installation, has what we call an alias name. So all of our toolboxes have an alias name that is a completely lowercase name that is effectively the name of the toolbox that you see in ArcPro. But again, you'll get all of the spelling and all the capitalization by looking at the help documentation. Now, when it comes to our geoprocessing tool names, like everything in Python, capitalization matters. It is important that buffer starts with a capital B and that analysis starts with a lowercase a. That is how that name exists, and that's how ArcPy and Python are going to know what you want from it. So you need to make sure that you're paying attention in the help documentation as well to the capitalization of all of the tools. Now here's where I need to point out that you're going to see two different naming conventions when it comes to the geoprocessing tools. You're actually going to see these even on the ArcPro help pages for each of the tool names. In the syntax area, which we'll decipher here in a couple of slides, you're going to notice a newer updated version of a naming convention, which is to put ArcPy dot the toolbox alias, all lowercase, dot the tool name, and then the tool parameters, what's required for the tool to run. So ArcPy.analysis.buffer. Now look below that. So in every help page for ArcPro, you're going to see the syntax. Then it's also going to give you very nicely example code at the bottom of the page. And notice in the example code for buffer is the older naming convention, ArcPy.the_toolname_analysis. Now both of these are heavily used. You'll notice that Esri is migrating to the top one, the ArcPy.toolboxname.tool. However, you'll notice that your textbook and most of my code and most code for anyone who's been doing this for more than a couple of years uses the bottom methodology where we have the tool name _ toolbox alias, just because that's how it was done before they came up with the other naming convention. So don't let that throw you. My best suggestion is just to choose one that you're more comfortable with, and then just remember that if you're looking at something that's different, that it's just the toolbox name might be in a different place than the tool name. And still, capitalization matters. All right, so these toolbox aliases. Here is an example of some toolbox aliases. The analysis tools, which is where the majority of your tools for doing your GIS data live. Its alias is analysis. The conversion tools, everything that would allow you to migrate data from one data model to another, is in the conversion tools toolbox, which its alias is conversion. Data management tools, that's where all of your projection tools are going to be found. That's one we're going to use heavily as well in this class, and the alias for that toolbox is management. Geocoding tools, that alias is geocoding, and spatial analyst tools, the alias for that toolbox is SA. Now, remember, when we look into toolbox, when we open up these toolboxes, there are also sub-toolboxes that help to categorize our tools and organize them. When it comes to ArcPy, we're not worried with those sub-toolbox names. You're only worried with that top-level toolbox name. So even though a tool may live 3 toolboxes buried underneath the analysis tools toolbox, that's okay. We don't care about that. We just care that it is in the analysis tools toolbox. So there will only be one toolbox alias per tool. All right, so geoprocessing tool syntax. So syntax rules, and syntax is incredibly important. We've talked about syntax with some of our Python rules earlier in the semester, but I just want to remind you of the definition of syntax. So in linguistics, it means the arrangement of words and phrases to create well-formed sentences in a language. And in Python and in ArcPy, your syntax is actually a hard-coded rule. You can't get loose with it and start to flip things in different orders. Things have to go in the same order every time. So in programming, we're just creating lines of code instead of sentences we speak, but they have a very hard-coded set of rules that they must adhere to. So syntax is going to govern our spelling and our capitalization of modules, functions, methods, and parameters, and also what a tool is required to run, which is what we talk about as our tool parameters. So that's why on the help documentation for every tool online, you're going to see a syntax area. The syntax gives you effectively the sentence structure for each of the tools. So you'll see here that we're looking at the syntax for the clip tool. And to call it with ArcPy, it's arcpy.analysis.clip. Remember, you would also maybe see this as arcpy.clip_analysis. And then after that, it's going to tell you what that tool needs in order to run. And that's part of its syntax. The things that are necessary that fall within those parentheses that are then described down below, those are individual parameters that each have their own description and explanation underneath there. All of that together is the syntax for an individual tool. Now, this is not new to you. You have already dealt with syntax and parameters every time you run a GIS tool. You've just seen it in a form when you open up your geoprocessing tools. So every time there is a box for you to fill out, that is an input parameter for that tool to run. Some parameters are required, some parameters are optional, some have defaults. All of our tools are different. Remember, when we look at them, we scroll all the way to the bottom of the tool and make sure we understand everything that we need to fill out. The same is true when we're scripting this. Each of those boxes that we would fill out for the tool are those things that are listed in the parentheses of our syntax for our tool. So let's decipher here a little bit our clip analysis syntax. So number 1 there is our geoprocessing tool name within ArcPy. So arcpy.analysis.clip. Remember, that could also be arcpy.clip_analysis. The second thing you see there are all of our required parameters. Anything that's listed within the parentheses without curly brackets around it, just listed out there, are things that have to be put into that parentheses. There has to be something put in there in order for the tool to run. Anything that's in those curly brackets, like number 3, those are optional parameters. Those are things that you don't have to put in anything within the tool when you're scripting it out, and the tool will run just fine. And number 4 here, when you're looking at help, is the explanation. So if you're looking at this and you're like, okay, clip needs an in feature. I don't know what an in feature is. Just go down below, look at the parameter, and look at the explanation. So the in features, that's the features to be clipped. And then look over there at data type, a feature layer. So okay, this is going to be a data set, right? So clip features, the features to use to clip the input features. So that's kind of like my cookie cutter. That's a feature layer as well. Okay, so I know that I need data sets. I need the name of a data set that for my in feature and name of a data set that exists for my clip feature. Out feature class, the feature class to be created. So it's a feature class. All right, so that I know that's going to be something that's new, that's created. It's an output. Anytime you see out, that means it's something that's going to be created that doesn't yet exist. Anytime you see in, that means it has to be an existing data set. Now you'll notice here that you see feature layer versus feature class. Feature layers are for when you are running these tools, scripting them within ArcPro, within a live ArcPro session. And all of the data sets that you pull into a map then get converted to what's called a feature layer. And you can access them through the feature layer, which is basically a memory copy of the data set to put in the tools. We are going to do only standalone scripting. We're going to do very little scripting within the ArcPro window because what we want to do is build robust Python scripts that can run some serious geoprocessing tools for us without even having to open up ArcPro. So for our purposes, anytime you see in the help documentation feature layer, it's going to be synonymous with feature class because a feature class is an actual data set on disk. It's either a geodatabase feature class or a shapefile feature class. So don't let that feature layer terminology throw you. It just means it needs to be an existing data set. All right, let's talk a little bit more about these optional parameters. They're optional because they're not required for the tool to run. They will always have, however, a default option that runs if you don't populate the parameter. And you need to make sure you know what that default is. How do you know what that default is? Well, you read the help documentation for the tool. So let's go back one and let's look at our syntax for clip. And we'll notice that we had one optional parameter called cluster tolerance. All right, so let's see what this is. It says it's the minimum distance separating all feature coordinates as well as the distance a coordinate can move in X or Y or both. So this is what's happening while the tool is running. Set the value higher for data with less coordinate accuracy and lower for data with extremely high accuracy. All right, so it says that it's a linear unit, and it says changing this parameter's value may cause failure or unexpected results. It's recommended that this parameter not be modified. It has been removed from view in the tool dialog. By default, the input feature class's spatial reference property is used. So that's your key. By default, the input feature class's spatial reference XY tolerance property is used. So that's how you know what it's going to be populated as. And the caution here is for this particular tool telling you don't mess with it. Just leave it empty and it will take the default that's associated with your data set, and that is the best practice for using this tool. But that's what you want to do. You want to make sure you read the explanation for your optional parameters to understand what's going to be run by default in the background. And if for some reason it's an optional parameter that you do want to adjust, that's when you figure out what it is you have to type in there in order for it to run properly. All right, so there are going to be tools, however, that have more than one optional parameter. And you might want all of those optional parameters, or you might only want one of them, and you need to see how to manage for that within your code. So let's look at this example here for buffer. So this is a syntax, so this is for buffer underscore analysis, which remember is the same as analysis.buffer. Buffer has a set of required parameters. It has in features, out feature class, buffer distance or field. So it has 3 required parameters. It also has a set of optional parameters: line side, line in type, dissolve option, and dissolve field. It has 4 optional parameters. Well, in our first example here, we want to buffer our streams. We want to buffer them on both sides, which if you read the documentation, you'll see that the default for line side is both. You'll then see that the default for line in type is to cap it off, squared capped on the end. Then you'll see that the dissolve option is, there's multiple dissolve options. You can dissolve all or dissolve none. The default is actually dissolve none. And then dissolve field is a place where you can put in a field that you might want to have your buffer tool pay attention to. So in this first run of the buffer analysis tool, we have an input feature class of streams.shape. We have an output feature class. This is what's going to be created from the tool. We've named it streams_buff.shape. We've put in the required buffer distance. It's 100 feet, and just notice that you'll figure this out from the help documentation that for buffer tools, you put in the unit, the number, and then the unit that you want to use. Now, we don't need to worry, we didn't want to change line side and line in type. We just want to take the default. We don't need to put anything in there. There are 2 ways to put in placeholders for optional parameters so that it would skip over those and allow you to get to the one that you want to use. One methodology is just doing 2 quotation marks, an open quote and a closed quote, and that will hold the place. The other methodology is to put in the pound sign in between the two quotes as an indicator to ArcPy to skip over those and just take the defaults. Now notice this has all led us up to be able to get to that second to last optional parameter of dissolve option, and we wanted to dissolve all. We didn't need to change the dissolve field. We didn't have a field, so we can just leave that blank. We don't have to put anything in. You could put a placeholder if you wanted, but it's not required because you're not having to move over that optional parameter to get to another one past it. So we'll play with this, and I'll give you plenty of examples throughout the class, but this is an example of taking advantage of those optional parameters and being able to get to the ones you want and ignore the ones that you don't need to change. All right, now let's talk about those parameters that are our GIS data. So remember that your GIS data lives on disk somewhere, right? It has an entire string that usually starts off with a drive letter about where it's living. Anytime a tool needs your data, it needs that entire string. It needs that entire pathway to get to your data. Now there are two ways that you can make this easier for yourself. Number one is just to set up a variable to hold your data set name, including the path. So here's an example where we're setting up the variable suitable veg to be equal to a geodatabase feature class called suitable vegetation. That way, every time we put this data set into a tool, we don't have to type that big long red string, right? All we have to do is type suitable veg because it holds that text string. The other way to do this is to set up your workspace environment to then be sitting in the location where all of your data is. So you set up the workspace, and then that is where all of your data, all of your tools are looking for your data, and that's where all of your tools will by default put your output data sets if you don't manually change it. So if we go back a slide and look at this buffer analysis example, you'll notice that it's just the data set names that are in those in features and out features. I don't have the big long string telling me where they're living on disk, and that's because in order for this line of code to work, before it I would have had to set up the workspace where streams.shape lives, and by virtue of just giving the output the name without any other location on disk means that the streams buff is going to be saved in that same workspace. So there's two methodologies. You can either set up your data sets to live in a variable, or you can set up a workspace, which is going to be where all of your data would live and all of your new data sets would be saved. All right, that's just another reminder, a final reminder about directory path rules. We've talked about this a lot, and we're going to continue to talk about it as a reminder, but Python really cares about the backslash, right? The backslash is an escape character for Python. However, that's how your computer stores the directory path for where anything sits on disk. So you need to do something to modify that. So one thing is you can do is to flip them all to be forward slashes. That's what Python traditionally wants. You can also go in and put a second backslash. So that double backslash allows Python to not escape and read through that string. You can also keep the front slash, but put the string literal R in front of the path. And that's going to mean that's going to tell Python everything that follows this R in the quotations is a string literal, meaning that I should not escape out from anything. So those are three different methodologies. You'll see all of them in the codes that you see in the book and online and from my course material. You'll see me bounce around because I think it's good for you guys to see different methodologies. I just suggest for you that you choose a favorite and maybe stick with it throughout the class. That way you've reduced one potential error in your code because you're not picking and choosing which of these you're going to use. And especially within a single script, you need to just choose one methodology and remain consistent because that's what's going to help your troubleshooting be easier when you go back through and try to find any particular spelling errors or capitalization errors that might be causing things not to work properly. All right, so that was a lot of information about our tools and our tool syntaxes, how to read through that, how to decipher that syntax, different methodologies that we have for our tool names, and then also a final reminder about our directory path rules in Python.